Alright, so in this video we are going to cover two things. We are going to cover division of decimals with word problems, but I'm also going to mix in adding decimals with word problems, subtracting decimals in word problems, and multiplying decimals in word problems. So it's really going to be a lesson about differentiating between which operation to use. So your goal for this lesson is I can perform operations with decimals to solve word problems. So how do I know, first of all, if it's a division word problem? So we're going to look for the same things that we looked for when we did fractions with division word problems. So the first thing we're going to look for is, are we splitting something into groups? So for example, dividing 5.25 gallons of water among 3 people. 13.25 pizzas shared by a party of 12. The other thing we're going to look for is how much can be made from something. Now, I know that sounds really weird, but think about if you have, for example, 9.1 pounds of fruit and you're trying to make 7 salads. So how much, meaning 7 salads, can be made from something, 9.1 pounds of fruit? How many dresses, so that's the something, can be made from 2.75 yards of fabric? That's how much, okay? So now, we're going to annotate these word problems in the same way that we always do. We're going to read the problem once. We're going to highlight the question in one color, so make sure that you have your 2 colors handy. And then we're going to determine what our operation is by highlighting the words that tell us the operation. If drawing a picture helps us, we're going to draw it. If it doesn't help us, we're not going to. Remember that annotating is a tool that we use in order to help us solve word problems more efficiently and correctly. It should not take terribly too much longer, and in fact these steps altogether should take no more than 30 seconds. Okay, all right, as our last bit of business before we get started, as with dividing fractions, we need to know which number goes first when we are dividing decimals, and we're going to use the same rule that we talked about when we're dividing fractions. So which number are we chopping into parts? Which number are we splitting up? Which number are we spreading out? Which number are we dividing? Which number are we sharing? Okay, so for example, how do you share 68.5 gigabytes of RAM with a family of 4 people? Well, in this word problem, which is the number that you're chopping up into parts? Are you chopping the family of 4 and sharing it with the gigs of data, or are you chopping up the data and sharing it with the family of 4? Well, you should have said that you're chopping up the gigs of data and sharing it with the family of 4. So that's the number that's going to go first. I will say that with decimals, it is significantly easier to determine which number goes first. All right, so Billy runs daily as a part of her exercise routine. She ran 8.3 miles on Monday, 5.1 miles on Tuesday, and 4.25 miles on Wednesday. How many miles did she run this week? So we're going to go ahead and highlight our question. How many miles did she run this week? And then what is our key word? So we don't have our word total or altogether here, but there's something about it that signals addition. So it says that we have this distance Monday, this distance Tuesday, this distance Wednesday, and it's asking us how many miles this week. And so that alone is going to go ahead and signal addition. Now, we can add up all these numbers all together, or we can add up 2 at a time and then add in the third one. Whatever your preference is, you can go ahead and do. I like to add up 2 at a time. So I'm going to do 8.3 plus 5.1. Make sure that your decimal points are lined up. 3 plus 1 is 4. Bring down my decimal, and then 8 plus 5 is going to be 13. Now I'm going to take that 13.4 and I'm going to add it to the 4.25. So I'm going to put my decimal point first to make sure that I'm lined up. The number next to my decimal is a 4, and on the other side is a 0.25. Then I'm going to just go back in and add my placeholders. So 0 plus 5 is 5, 4 plus 2 is 6. Bring down my decimal. 3 plus 4 is 7, 1 plus 0 is 1. So the answer to the problem is she ran 17.65 miles. All right. Next problem. Tom bought a DVD for $12.24 and some snacks for $8.62. If he started with $84.50, how much does he have left? So this question highlights the importance of why we highlight the question. So let's highlight the question. If he started with $84.50, how much does he have left? So it is a two-step problem because it first wants us to add and then subtract. It's asking how much he has left, which is telling us subtraction. But in order to get to the subtraction, I need to add up the two numbers first. Okay, so let's go ahead and add up the two numbers first, the price of the DVD and the price of the snacks. So 12.24 plus, and line up my decimal here, the number right next to the decimal is an 8, and then a 62 on the other side. Go back and add my placeholder. 4 plus 2 is 6. 6 plus 2 is 8. Bring down my decimal. 2 plus 8 is 10. Carry the 1. 1 plus 1 is 2. So here I have $20.86, but that's not what the question is asking me. It's asking me how much he has left. So he had $84.50. So $84.50 minus $20.86. Okay, now 0 minus 6, I can't do it, I need to borrow. So the 5 becomes a 4 and this 0 becomes a 10. 10 minus 6 is 4. 4 minus 8, can't do it, I need to borrow. The 4 becomes a 3 and this 4 becomes a 14. 14 minus 8 is 6. Bring down the decimal. 3 minus 0 is 3. 8 minus 2 is 6. So how much does he have left? $63.64. All right, the monthly rental for an apartment is $412.50. How much would Terrence have to pay if he lives there for 8 months? So we're going to go ahead and highlight our question. How much would Terrence pay if he lives there for 8 months? And then we need to determine our operation. So what I see here is repeated addition. So I see that the apartment costs $412.50 a month. See here it says monthly. And then I see 8 months. And repeated addition tells me that it's a multiplication problem. Because I could do 412.50 added to each other 8 times, or I could just do 412.50 times 8. So 8 times 0 is 0. 8 times 5 is 40. Carry the 4, put the 0 on the bottom. 8 times 2 is 16 plus 4 is 20. Carry the 2, put the 0 on the bottom. 8 times 1 is 8 plus 2 is 10. Carry the 1, put the 0 on the bottom. 8 times 4 is 32 plus 1 is 33. Now we need to determine where to put our decimal. Go back to the original problem. How many numbers are after the decimal? No decimal here, and there's 2 numbers here. So I'm going to start over here, and I'm going to go 1 and 2. So it is going to cost Terrence $3,300.00 to live in that apartment for 8 months. Okay, strawberries are on sale for $2.30 a pound. How much did Leah spend if she bought 3.5 pounds of strawberries? So let me go ahead and highlight my question. How much did Leah spend if she bought 3.5 pounds of strawberries? Okay, now what is the operation? Again here, I see repeated addition because I see that they're $2.30 per pound and she bought 3.5 pounds. I could add 2.30 to itself 3 times and then another half of a time, but it would be more efficient to just multiply it. So 2.30 times 3.5. All right. 5 times 0 is 0. 5 times 3 is 15. Carry the 1. 5 times 2 is 10 plus 1 is 11. I'm done with the 5 and I put a 0 here as a placeholder. 3 times 0 is 0. 3 times 3 is 9. 3 times 2 is 6. Now I'm going to add them all up. 0 plus 0 is 0. 5 plus 0 is 5. 9 plus 1 is 10. Carry the 1. 1 plus 1 is 2. 2 plus 6 is 8. How many numbers do we have after the decimal in the original problem? Well, there's 1, 2, and 3. So I start from here, and I'm going to go 1, 2, and 3. Now, how much does it cost? $8.05. Because that 0 at the end, we don't need it. All right, Jan bought 4 pounds of candy for $12.25. What is the average cost per pound to the nearest cent? Now, when a problem asks you to round to the nearest cent, we are talking about money. So money is written in a very specific form. You can have as much money as you want on the left side of the decimal point, but there's only 2 spots on the right-hand side of the decimal point. So when we ask you to round to the nearest cent, we are asking you to round to the nearest hundredth. That's very, very important to remember. Okay? So that being said, let's go ahead and annotate it. What is the question? What is the average cost per pound to the nearest cent? Now, what is my operation? Well, she bought 4 pounds of candy for $12.25. What is the average cost per pound? This per pound is telling me I am dividing something up into parts, so I have a division problem here. But what am I dividing? So she bought 4 pounds of candy for $12.25, and I want to know the cost per pound. Am I dividing the candy up into money, or am I dividing the money up into pounds? I'm dividing the money up into pounds. So this $12.25, it's what is going to go first. So my problem is going to read 12.25 divided by 4. And now I'm going to make it look like an actual division problem by putting it into my bracket, my division bracket. Now, I have a whole number on the outside, so there's no need for me to move any decimals around. So I need to move my decimal point to the roof, and I'm going to go ahead and divide. 4 goes into 1 0 times. 0 times 4 is 0. Subtract. 1 minus 0 is 1. Bring down the 2. 4 goes into 12 3 times. 3 times 4 is 12. Subtract. 12 minus 12 is 0. Bring down the 2. 4 goes into 2 0 times. 0 times 4 is 0. Subtract. 2 minus 0 is 2. Bring down the 5. 4 goes into 25 6 times. 6 times 4 is 24. Subtract. 25 minus 24 is 1. I have nothing left to bring down, so I add a 0 and I bring it down. Okay, 4 goes into 10 2 times. 2 times 4 is 8. Subtract. 10 minus 8 is 2. And I need to add another 0 and bring it down. 4 goes into 20 5 times. 5 times 4 is 20. Subtract. 20 minus 20 is 0. Nothing left to bring down. Now, my answer here is 3.0625, but I need to round to the nearest hundredth, which is this spot right here. So the number after it tells me where to go, and it's a 0 through 4, so I stay on the floor, and so my answer is $3.06 per pound. All right, if Miss Seckerson needs 29 pencils and they come in packs of 5, how many packs should she buy? Remember, you can't buy half a pack of something. So if I go to the store and I need to buy 12 hot dog buns, but they only come in packs of 5, think about it. how many packs do I need to buy? I can't rip open half a pack and just walk to the counter with a couple of extra buns, okay? It doesn't work like that. So let's go ahead and highlight our problem so we can do our annotating. So what's the question? How many packs should she buy? And what is our keyword here that's going to tell us our operation? So I see this word packs here. Which is going to tell me that I'm going to probably be dividing something into parts, okay? Now, is it going to be 5 divided by 29 or 29 divided by 5? So, let me read it again. If Miss Seckerson needs 29 pencils and they come in packs of 5, how many packs should she buy? So, I'm going to do 29 divided by 5. So 29 is going to go into my bracket here. All right. So 5 goes into 2, 0 times. 0 times 5 is 0. Subtract. 2 minus 0 is 2. Bring down the 9. 5 goes into 29 5 times. 5 times 5 is 25. Subtract. 29 minus 25 is 4. Now, what happens is, I have nothing left to bring down, but I need to add a 0 here, but I don't have a decimal point. I need to add a decimal point and add a 0 and bring it to the roof. So that's a big, big, big step. Add the decimal point, bring it to the roof, add a 0, and bring it down. Okay? So 5 goes into 40 8 times. 8 times 5 is 40. Subtract. 40 minus 40 is 0. Now let's go back up to our original problem. Remember, you can't buy half a pack of something. So if she needs 29 pencils, how many packs does she need? 5.8. So do we round up or down? We need to round up to 6 packs. If she buys 6 packs, 6 packs times 5 pencils, she's going to end up with 30 pencils, meaning she's going to have a couple extra. If she were to buy 5 packs, 5 times 5 is 25 pencils, she's going to be short pencils. That's not going to work. So she needs 6 packs. All right, find the total cost of the following groceries. 3.89 for apples, 10.64 for steak, 1.05 for eggs, and 1.99 for a loaf of bread. All right, let's go ahead and annotate our problem with our highlighter. So the question is actually in the beginning. Find the total cost of the following groceries. And right there, it says total cost, which tells me addition. So I'm going to go ahead and add these up. You can make one large list and add them all up in one shot. I like to do smaller chunks myself so that my decimal points don't get lost. So I'm going to do 3.89 plus 10, make sure my decimal point is lined up, plus 60.64. So 9 plus 4 is 13, carry the 1. 8 plus 6 is 14, plus 1 is 15. Bring down my decimal. 1 plus 3 is 4, and then 1. All right, so I took care of that and that. Now I have 1.05 for eggs and 1.99 for a loaf of bread. 5 plus 9 is 14. 1 plus 9 is 10. Bring down the decimal. 1 plus 1 plus 1 is 3. Now my last step is to join these two guys together to get my total price. So I have 14.53 plus 3.04. 3 plus 4 is 7. 5 plus 0 is 5. 4 plus 3 is 7. And then 1. So my total price for groceries is 17.57. All right, Dylan finished a 220-yard dash in 36.4 seconds. Antonian finished the 220-yard dash in 33.9 seconds. Who ran faster and by how much? So I'm going to go ahead and highlight my question. And there's two questions. Who ran faster? By how much? So what is my operation? By how much signals to me subtraction, okay? Because it's asking me a how much more question. So I'm going to go ahead and subtract my two numbers here, or my two decimals. So 36.4 minus 33.9. 4 minus 9, I can't do it. So I'm going to borrow. The 6 becomes a 5, and that 4 becomes a 14. 14 minus 9 is 5. Bring down my decimal. 5 minus 3 is 2, and 3 minus 3 is 0. So the difference was 2.5 seconds, but my question was asking me two things. Who ran faster and by how much? I answered by how much, but who ran faster? So now compare them. Which is the smaller decimal? Antonian ran faster by 2.5 seconds. All right, Mr. Adams drives a school bus 5 times per week. If each trip is 35.8 miles, how many miles does Mr. Adams drive in all? So let me get my highlighter. How many miles does Mr. Adams drive in all? And it looks like here that I have repeated addition. So I have that each trip is 35.8 miles, and he does it 5 times per week. Also right here, this number, or this word times, tells me that it's times. Okay? So I have 35.8 times 5. So 8 times 5 is 40. 5 times 5 is 25, plus 4 is 29. 5 times 3 is 15, plus 2 is 17. Now, where's my decimal point? How many decimals or how many spots are in after the decimal in the original problem? There's 1 here, and there's no other ones. So I'm going to start here and move over 1. So he drives 179 miles each week. All right. Alexis bought 8 notebooks that each cost $1.49. How much did she spend in all? All right, so the question is how much did she spend in all? And this right here is repeated addition. They each cost $1.49. She bought 8 of them. So I could do 149 plus 149 plus 149 plus 149 and do that 8 times, or I could simply multiply them together. 1.49 times 8. So 9 times 8 is 72. 8 times 4 is 32, plus 7 is 39. 8 times 1 is 8, plus 3 is going to be 11. And then my decimal, how many numbers are after the decimal in the original equation, or in the original problem? None over here, and then there's 1 and 2 over here. So I'm going to go 1, 2. So the total cost that she spent was $11.92. All right, Corey bought 5 packs of gum for $9.79. How much did each pack of gum cost? Round to the nearest cent. So you should be familiar with this, round to the nearest cent. Remember, round to the nearest cent means round to the nearest hundredth, because we're talking about money, okay? So it wants to know how much each pack of gum cost. So let's go ahead and highlight our question. How much did each pack of gum cost? So what's our operation? Well, it wants to know each pack of gum. And so that's usually going to signal dividing something up, and so that's going to tell us division. So if we want to know how much each one costs, we are dividing the money. So that's going to be $9.79 divided by 5. So let's go ahead and set it up properly here. Bring my decimal straight up to the roof, and we'll go ahead and divide. 5 goes into 9 one time. 1 times 5 is 5. 9 minus 5 is 4. Bring down the 7. 5 goes into 47 9 times. 9 times 5 is 45. Subtract. 47 minus 45 is 2. Bring down the 9. Oops. 5 goes into 29 5 times. 5 times 5 is 25. Subtract. 29 minus 25 is 4. Add a 0, bring it down. 5 goes into 40 8 times. 8 times 5 is 40. Subtract. 40 minus 40 is 0. So you end up with 1.958. But we need to round to the nearest cent, which is going to be the hundredth. This 8 right here tells us we're going to round up. So it's going to be $1.96 per pack. All right, hot dogs come in packs of 8. If you plan to make 68 hot dogs for a party, how many packs of buns should you buy? Remember, you can't buy half a pack. So this is similar to the pencil problem that we just worked on not too long ago. So let's go ahead and highlight. How many packs of buns should you buy? Okay, and then we need to determine our operation. So let's see here. How many packs of buns should you buy? Well, we are dividing because we need 68 hot dogs. They come in packs of 8. So we're dividing it by the number of packs. Okay, so we're going to do 68 divided by 8. And then let's put it into the proper bracket here. All right, 8 goes into 6 0 times. 0 times 8 is 0. Subtract. 6 minus 0 is 6. Bring down the 8. 6 goes into 68 8 times. 8 times 8 is 64. Subtract. 68 minus 64 is 4. Now, we can't just slap a 0 and bring it down. We need to add a decimal, bring it to the roof, add a 0, and bring it down. Whenever you add a 0, you always want to make sure that you have an existing decimal point there. Very, very important. Okay? So 8 goes into 40 5 times. 5 times 8 is 40. Subtract. 40 minus 40 is 0. Now, you need 8.5 packs, but you can't buy half a pack at the grocery store. So how many do you need to buy? 9 packs. All right, that is the end of this mixed operation word problem lesson. We have many, many more to practice in class.